Okay, let's talk about a material that is literally all around us. It's in your kitchen, it's holding up buildings, and it's at the very edge of human technology. It really is a modern-day superhero. But like any good superhero story, this one has a pretty complex secret, a hidden cost.
So here's a wild question for you. What could your plain old kitchen fork possibly have in common with a multi-billion-dollar fusion reactor? You know, the kind trying to build a star right here on Earth? Sounds impossible, right? Well, they actually share a secret identity. There's one material that makes both of them work.
And that material, of course, is stainless steel. I mean, it is one of the most versatile and essential materials of our time. It's quietly doing the heavy lifting for everything from our daily meals to our biggest, most ambitious quests into the cosmos.
So what's the big deal with it? What makes it so special? Well, it really comes down to three main superpowers. First, it has this incredible resistance to rust and corrosion. Second, it's just unbelievably durable. It lasts forever. And third, it has fantastic structural strength. That trifecta is why it's the go-to choice for just about everything, from massive skyscrapers to delicate surgical tools. Now here's something you might not know. Stainless steel isn't just one single thing. Nope, it's actually a huge family of different materials. Think of it like a team of specialized alloys, where each one has its own unique recipe and its own set of superpowers. The whole thing can be broken down into four main family groups. You've got your Austenitic, your Ferritic, Duplex, and Martensitic. They're like different branches of the family tree, and each one is optimized for a totally different job. And this chart really breaks it down nicely. Take a look at Austenitic. That's the most common one. It's generally not magnetic and has really high corrosion resistance. Then you have Duplex, which is like the powerhouse of the family. It's a mix of the other two, it is magnetic, and its corrosion resistance is off the charts. After that, there's Ferritic, which is a great magnetic, cost-effective option, and finally, Martensitic. This is the one you can make super hard, which is why it's perfect for things like kitchen knives and medical instruments. And this brings us right back to that crazy question from the beginning. The ITER fusion reactor, that project building a sun on Earth? It relies on a super special grade of austenitic steel for its main structure. Why? Because it's strong, it's stable, and you can weld it reliably, all properties you absolutely need when you're trying to contain plasma that's 10 times hotter than the center of the sun. So yeah, from a simple fork to harnessing fusion power. Pretty incredible. But like we said, every superhero has a weakness, a kind of kryptonite. And for stainless steel, its greatest strength hides a really significant environmental cost. And the problem is probably not coming from where you think. Just to set the stage, the steel industry as a whole is responsible for a huge chunk of global CO2 emissions. We're talking somewhere around 7 to 8% of the total. That is a massive number, and it's a footprint the industry knows it has to deal with. But for stainless steel producers, the biggest challenge is something called Scope 3.1 emissions. And this is key. This isn't the smoke coming out of the steel mill's chimney. No, this is the carbon footprint of all the raw materials before they even show up at the factory.
And here's the great paradox. As experts at Roland Berger point out, the very ingredients that give stainless steel its superpowers, things like chromium and nickel that are added in, well, producing those ingredients is an incredibly energy-intensive process. So the hero's strength is, ironically, the source of its biggest problem.
But, and this is a huge but, this story has a path to redemption. And it's built on one of stainless steel's most amazing qualities, the power of recycling. Get this, stainless steel is 100% recyclable. But it gets even better. It can be recycled over and over and over again, literally forever, with absolutely zero loss in quality. The fork you recycle today can become part of a skyscraper tomorrow, and it will be just as strong as the day it was first made. And the impact of that is just staggering. When you use recycled scrap metal instead of digging new materials out of the ground, you cut the energy needed to make new stainless steel by up to 70%. That is a massive saving. And if the energy savings are good, the emission savings are even better. Going the recycling route slashes CO2 emissions by up to 80%. Remember that whole upstream emissions problem? Well, this is how you tackle it head-on, by cutting the need for those super energy-intensive raw materials in the first place. And the wins just keep on coming. It's not just about energy and emissions. When you recycle stainless steel, you also reduce destructive mining, you use 40 to 50% less water, you keep a huge amount of waste out of landfills, and you preserve our planet's finite resources. It is a win-win-win-win. So, recycling is our most powerful tool right now, no question. But the industry is looking even further down the road. They're on a quest to completely decarbonize the whole process and create something called green steel.
So how do we get there? It really boils down to a three-part recipe for the future. First, you swap out fossil fuels for green hydrogen, which only produces water as a byproduct. Step 2, you power the furnaces with 100% renewable electricity. And the final piece of the puzzle is to maximize the use of recycled scrap to create a truly circular system. Now look, this isn't going to happen overnight. It's a huge shift, but it is the clear path forward.
So, you see, stainless steel is so much more than just a simple metal. It's a permanent material, one that can serve us for generations. And while it has that hidden environmental cost, its power of infinite recyclability and the quest for green steel offer a clear road to redemption. It's a material that's being redesigned to become a core part of a sustainable future. The question now isn't if it can be a green material, but how fast we can make that happen. Thanks for watching.
Don't forget to like and subscribe for more How Meets History.